Alright, this lesson is called Mathematical Patterns. The learning target states that you can define a sequence recursively and use sequence notation. So that's what we're going to be focusing on is the term recursively, which you have heard in Algebra 2, as well as sequence notation. So consider these sets of numbers. First one, 6, 2, negative 2, negative 6, negative 10. And so forth. All that we're looking at here is going from 6 to 2 to negative 2, is recognizing what is the difference, what's the jumps here. So we can see here that these numbers are going down by 4. Okay, second one, 5 to 10 to 5 halves to 5 fourths. So we can see that that's not either being added or subtracted. So obviously it's either multiplication or division. So you can say that 10 to 5 is being divided by 2. Another way to say that is just being multiplied by 1/2. Multiplication is always a good term to use in this case. Okay, the third one is a little bit different. So 1 to 4 to 9 to 16 to 25. So 1 to 4, we know that that's adding 3. But 4 to 9 is adding 5. And 9 to 16 is adding 7. So the jump isn't consistent there, but it is consistent in between those two numbers. So 3 to 5 is adding 2, and 5 to 7 is adding 2, and so forth. So that term is just a little bit different there. But you can see the sequences, they have three different options in how they're written, or how they're ordered. Okay, the previous number sets that we just looked at are called sequences. And sequences are ordered lists of numbers. Each term, or each number is called a term. The ... that you'll find at the end of the sequence indicates that the sequence continues on and on. In general, a sequence is written as U1, U2, U3, and so forth. U1 is your first term, U2 is your second, so whatever is in this subscript term indicates what number it is within that sequence. U sub n is your nth term, and then U sub n minus 1 is the term that comes before your nth term. Alright. Is a sequence a function? So reviewing what a function means. A function means that every x value has one y value. So every input has one output. So is a sequence a function? In other words, is it ever going to repeat? And in this case, it isn't. Like you'll never have 6, 2, 2 again. So because of that, yes, a sequence is a function. Okay, if it is, what are the domain and range? So domain, we know, is your input. And another way of saying input is your x values. In this case, our input and our x values are integers. So it's your number of terms in the sequence. So it's like your U1 and your U2 and your U3. So it's your integers goes with your domain. Okay, your range is your output, or your y values. In this case, our range, since it is the output, those are the numbers within your sequence. So we'll just say sequence here. Taking a look at this list, what we're preparing for is to graph on the next slide here. So it's a good idea to make an x and y table chart, just recognizing what is your x and what is your y. So remember, x, in this case, we have 5 terms that are listed, so we have 5 integers. So our x values go up to 5. We could keep going if we wanted to. And then our y values, so your very first term is 6. Your second term is 2. Your third term is -2. fourth term, -6, and fifth term, -10. So that just recognizes what is happening within these sets, and we can do the same thing with the second one here. All right, let's take a look over here. So we're going to graph this sequence, -1, 2, 5, 8, 11. Taking a look here, let's just make our X and Y table chart. We have 5 terms listed, so we're going to have 5 X values. Our first term is -1, second term is 2, third term is 5, fourth 8, and 5, 11. So you can see here that going from -1 to 2 to 3, or -1 to 2 to 5 to 8, that we have a jump of 3. Okay, so it's constant, it's going up. Graphing this is, just say 1, 1, 2, 2, 3, 5, say 4, 8, and 5, 11. Okay, pretend that that's straight. Okay, how could you describe this graph? Well, there's a couple different things, but since it's a line, we know that this is linear. So we could describe it as just saying linear. And what we're going to see in later lessons is that linear means arithmetic, or arithmetic means linear. So those two kind of go together. Okay, next one. Make a list here. Again, we have, in this case, we have 4 terms. So our domain goes to 4. First term is 10, second, 5, third, 5 halves, and the fourth is 5/4 graphing. I think what would be easier is to use decimals, so 5 halves is 2.5, and 5/4 is 1.25. All right, graphing this. 1 goes up to 10, 2 to 5, approximately there, 3 to 2.5, and 4 to 1.25. Alright, describing this is it is obviously not a straight line. So if it is not a straight line, we describe these graphs as exponential. And exponential graphs. We can see with these, that is a geometric, meaning that it was going down by division or multiplication, so meaning geometric. Okay, second part of this lesson is defining recursive. So, recursive means that the definition of a function from which the values of the function can be calculated. A sequence is defined recursively if these 2 conditions are in place. So the first is that the first term is given, and then the second is that there is a method of determining the nth term by using the terms that precede it, meaning that they come before it. So if those 2 things are in place, we have the first term, and then there's a method or like a formula to find the second, or the second, the third, the fourth, the fifth, and so forth. Then it is defined as a recursive formula. Define the following sequences recursively. Okay, well, defining it recursively, remember that there are 2 parts. So the very first part here is that we name the first term. So the first term inside of our sequence, we say u sub 1 equals -2. Next, we have to define the jumps. So from -2 to 3 to 4 to 7 is, we can see that you're adding 3 in between here. So adding 3 or subtracting, whenever we say that, this means arithmetic. Now, a formula for us to know is that the formula states this: u sub n equals u sub n minus 1, so the term that came before u sub n, plus d, or minus d, depending on if you're subtracting. So in this case, since we're adding, the recursive formula, so we say u sub n, so we don't know the nth term, this is what we would use to find it. And the term that came before it, so you keep n's inside of your recursive formula, but since we're adding 3, our difference is 3, we just add 3. And that is what is behind this. Okay, taking a look at the second one. So we go from 3/2 to 3 to 6 to 12. Okay, well, this is not either adding or subtracting. Okay, so that's always the first thing to recognize, is what's going on in your sequence. So going from 3/2 to 2, or kind of easier to see, like 3 to 6, we can see that we're going to multiply by 2. So if you're multiplying, then this is called a geometric series, or geometric sequence. Same thing is that we need to state the first term. So our first term is 3/2, or 1.5. But then the second one has a different formula. So this is u sub n equals u sub n minus 1 times r. Another way that you can see this is r parentheses u sub n minus 1. So kind of two different ways to write that. Our r here, or your ratio, is 2. So if r equals 2, then we're going to say u sub n equals, we could say 2 parentheses un minus 1. And again, that's what's behind here. Write the first 4 terms of each recursive sequence. So we're given the first term. What we're going to do with that first term is we're going to find out what is the second, what is the third, and what is the fourth term of this sequence. Well, it's pretty easy. So since you know that your first term is 1, so that's done. What we need to find then is what is the second, what is the third, what is the fourth. And we're going to use this recursive formula here. So our n, that is our nth term, saying what term do you want to find inside of your sequence? Well, we want to find our second term. So what we're going to say here is we're going to plug in a 2 for our n. So u sub 2 equals, and you just keep going with this, so u, wherever you see an n, plug in a 2. Want to find our second term, minus 4. Okay, well, if you solve for this u sub 2 minus 1, so our second term really equals our first term, minus 4. Well, our first term is given to us as negative 9. So our second term, we take our u sub 1. Remember, that was given to us, and that's negative 9. So we say negative 9 minus 4, which is negative 13. So that tells us that our second term is negative 13. Okay, using the formula one more time. Next, we find our u sub 3. Remember, that's u sub 3 minus 1 minus 4. So that's u sub 2 minus 4. Well, our second term was negative 13. So negative 13 minus 4 is negative 17. So you can see here that you're just taking the preceding term, the term that comes before it, and you're subtracting 4. So negative 17 then minus 4, negative 21. And we're done. Okay, second one. Our first term is 10. We need to find the first 4 terms. Using our formula here, we're going to say u sub 2. We're trying to find the second term. So it's negative 2, and plug in a 2 in for this n. So that's u2 minus 1. Okay, well, negative 2 times 2 minus 1 tells us our first term. So we're taking our u1, and our u1 is given to us. It's always given to you in a recursive formula. So our u1 is 10. So we're going to say negative 2 times So our second term is negative 20. Listing our first four terms, you can see here that you're just going to take that next term and you're going to multiply it by negative 2. So we have 10, negative 20, 40, and negative 80. And that would be our first four terms. Okay, last one here is a little word problem. So it says that a ball is dropped from a height of 9 feet. It hits the ground and bounces to a height of 6 feet. It continues to bounce, and on each rebound, it rises to 2/3 of the height of the previous bounce. We are going to write a recursive formula for the sequence that represents the height of the ball. Okay, well, the ball is dropped from 9 feet. So that tells you right away that your first term, remember recursive formula, you always name your first term. So our first term is 9. So it's starting off at 9 feet. If it is rebounding to 2/3 of the previous height of the bounce, well, 2/3 in this case, we're not saying that's adding or subtracting 2/3. We know that this is going to be a geometric series where we are multiplying by 2/3 of the previous bounce. So in that case, we would say u sub 1 is the first term, and then you want to say that we have u sub n equals, so we have our ratio as 2/3, parentheses, un minus 1. And that would be our recursive formula, and that's what we're going to use to find the next height of the bounces. So create a table and a graph showing the height of the ball on each bounce. Okay, this is what we did previously. So we have our x and y table chart, and we're going to graph this. So our very first height, our first bounce, even though it's not bouncing, but our first term is 1. And then our second term, so 2/3 of 9 is 6. And 2/3 of 6 for our third term is 4. And 2/3 of 4 for the fourth bounce is 8/3. Graphing this, we know that this is going to be exponential, so when you graph it, make sure that it is, otherwise you did something wrong. But we're going on our first term up to 9, our second term down to 6, third term down to 4, and our fourth term down to 8/3. We can see it's very slowly going to be approaching 0 there. Alright, then the last thing is that we are going to find the height of the ball on the fourth bounce. Well, what we can do here is we can just take what was our previous bounce. So on the fourth bounce, remember that you're really starting at 9, so you're not really, the ball has not bounced at 9. So the first bounce is really at 6, and then the second bounce is at 4, the third bounce is at 8/3. So to find the height of the ball on the fourth bounce, we need to take our previous bounce and multiply that by our ratio of 2/3. So that's 16 over 9 or approximately 1.8. And I'm pretty sure this was in feet. So there we go. Okay, that is it.